Hi guys, in this video we are going to explore how to perform grams to grams conversions given a balanced chemical reaction equation. Okay, so basically what we're going to do is pick up on the topic that we talked about in the previous video, this concept of a mole-to-mole conversion, and basically extend it to calculations where we are dealing with the amounts of reactants or products given in grams or mass. So a quick recap here, how to use mole-to-mole conversions. Remember, the general method for using a mole-to-mole conversion was to map out our conversion, map out which set of reactants and products we are wanting to convert between. Then use that balanced chemical reaction equation to construct a mole-to-mole conversion factor, and then finally carry out that conversion, do the math. Okay, so this seems great, but we run into a problem as soon as we run into the laboratory. When we are in a laboratory setting, we don't measure individual molecules. We don't even measure moles. There's no mole counter in the laboratory. What we measure are volumes or masses. And so if we are, for example, given the mass of a certain one of these reactants, and we want to figure out how the mass of product that we are going to form at the end of the day, then this method up here is going to have to be extended. But the good news, the basic outline will remain the same. So here's a general method for using that mole-to-mole conversion factor to carry out a grams to grams conversion. Okay, so we're going to start off just as we did before. Determine what reactant and product we really care about. Okay? Then what we're going to do is map out a conversion that uses the mole-to-mole conversion factor that we would under any other circumstances. But what we're going to have to do though is convert the given quantities which are given to us in mass into moles. And remember, we already have a conversion factor that does that. If you want to convert between mass and the number of moles, then the molar mass will do just that. So you can take that given reactant or product, wherever you're starting with, use the molar mass to convert that mass into moles, and then you're going to apply a mole-to-mole conversion factor and then convert the moles of the desired product back into mass. Once again, using a molar mass conversion factor. Okay, so this mole-to-mole conversion factor will be built up just as before using that balanced chemical reaction equation, right? But then you basically have two additional conversions involving the molar mass of the two reactants or products of interest that complicate or add to that conversion factor in order to get your final result. So there's a lot that goes on here. So let's jump into a solution, an example, in order to help make sense of this. So let's look at our favorite example of formation of water. And remember that we've already balanced this chemical reaction equation. And now let's answer the question of how many grams of product can we form given an initial quantity of 4.0 grams of O2. All right. So we know that the molar mass of O2 is right there about 32 grams. The molar mass of water is right there at about 18 grams. And we're going to go ahead and map out a conversion that will take us from our initial given mass in grams of O2, convert that to moles of O2 using that molar mass, which we just determined right here. Then use a mole-to-mole conversion factor to go from moles of our reactant to moles of product. And then finally, once you have moles of product, we will use yet another molar mass conversion in order to get grams of our product. Okay? Then we'll come in, we'll look at those stoichiometric coefficients, 1 for oxygen, 2 for water, to get our oxygen to water mole-to-mole conversion factor, and then simply put it all together. Start off with our given quantity it's 4 grams of O2, divide by that molar mass, and remember you must divide to make sure the units of grams cancel out. Now we're in moles of O2. Now you can multiply by this molar ratio, again making sure that moles of O2 are going to cancel out, so we're left in moles of product, and then multiply now by the molar mass of water so that moles cancels out and we are left with our desired product in units of grams. Okay, so see, we're basically doing the same thing with this mole-to-mole conversion factor, but we just have to translate our quantities at the beginning and at the end into the desired units of grams, right? Which we use our molar mass on either side. Okay, so now just as we saw with previous examples, right, we can use this grams to grams conversion technique to move, answer a variety of different problems regarding a chemical reaction equation. In this one, we're again forming water, but now we want to figure out how many grams of H2 are required to form a known quantity of water. Okay, so once again, we're going to now have to pull out our molar masses for these compounds of interest. So we're going to be looking at calculating the mass of H2. So we pull out the molar mass of H2, about 2.016 grams per mole. We already had the molar mass of H2O from the previous slide. Then we're going to map out a conversion that takes us now from our product, which is given in grams, to moles of that product. Then use a mole-to-mole conversion to get from moles of this product. So we're going to have to go to moles, right? Then we're going to have to go to mole, because this is moles of water. Then we're going to have to go to moles of H2, and then finally all the way back to grams of H2. Okay, so we've got this 3-step conversion process now. Looking at those stoichiometric coefficients though, we can quickly build up the conversion factor for the mole-to-mole aspect. We know our molar masses, so we can divide by the molar mass of H2O, get moles of H2O. It's a 1-to-1 ratio, so moles of H2 are going to cancel out. We get moles of H2, and then we multiply by the mass of that H2 to arrive at our final answer in grams. Okay, so there's a lot of different ways, as I said, that you can ask these problems, and it's absolutely essential that you become very familiar with how to perform these mole-to-mole and gram-to-gram conversions. And so what I've done is I've built a little simulation using the Wolfram CDF player. You can download, launch this little simulation, and basically it allows you, using this little slider bar up here, to modify the number of grams that you have coming into a given chemical reaction. And if you multiply the number of grams of O2, all these other values automatically update, letting you know, for example, how many moles of O2 that corresponds to, and how many grams and moles of H2 would be required to react with this given quantity, and how much product will be formed. So to see this little guy in action, I'll point out that you can hit the little plus sign here to open it up. You can even type in numerical values. So let's say I want to type in 4.78 grams of O2. As soon as I leave that field, the grams of O2 automatically updates. I know the corresponding number of moles, and I can see that it in fact requires 0.602 grams of H2 in order to fully react this 4.78 grams of O2, and if that initial amount of O2 fully reacts, we will end up with 5.380 grams of H2O at the end of the day. So using this little interface, you can literally move these around and make however many practice problems you want, and you can test yourself. You can say, hey, let's slide it down right here and pull this value up and say, hey, hypothetically, I've got this fixed amount of product, how much hydrogen is required, how much oxygen is required, work out the calculations, and then use the interface to check your work.